Hello. Today I want to talk about how to create some wind explosion. Let's I show you a quick example, and after we discussing this way to made it and the other way. This made way is a little unique because it using the very specific technique, and I suppose that it's be interesting to discuss it. So, for example, I have this simple wind explosion. Um, Definitely we have three ways how to make some this wind explosion. But I show you why I think that my method to create it it's have some good priorities from the other methods that we can use it, because this method can have as many explosion at the same moment as we want. For example, I can create more explosion or more explosion, and I have created very much explosion, and now bam, it was walk. So but let's discuss the other ways how to create it. First of all, it's the overlapping method. That means that we create some blueprint, we have something like sphere here, for example, and this sphere is expand sometime, and every that be in this sphere it's get some attribute. We have two attribute to read it. It's then our custom primitive data attribute. We can show it in every for example mesh or something like this. Here custom primitive data, we can set up it using our collision. You can find node for it. Or the second method, we can use get our material, for example, and set up parameter directly, like set vector float value, float parameter or something like this. What's the different? The main difference is that we custom primitive data works with the instant static mesh. So the base custom primitive data, that's it's unique to any instance mesh, and if we rewrite variables in the our material, that's the only one instance per all material, and that means that this for example our explosion affects for all material, and that's not something that we want to do. So the second method is then something like a fluid method. Basically it's then I suppose the best way to do it, but he have one big problem. First of all, fluid method in many implementations of it, have only one plane to do it. That means if we want to create, for example, some 3D explosion, we need to rewrite it the fluid method to myself, and it's a little more harder task than we talking. That's, I suppose I can say it, and and the third method, it's they're using some cheats and not very elegant way to do it. For example, we can use it our distance fields, generate distance fields for every our geometry that influence to our grass after set up the invisibility of this geometry, or just not render in main thought, and then many other things. But why I set up this is then one of the specification of implementation first method. That means that we get our near variable some interesting thing, but this is method is full dynamically. Why I choose this method? First of all, we need to understand that my main goal is to influence to this grass. This grass is not the simple grass that we, for example, we can spy on using foliage. This is grass using our material system, and we can't just overlap it. We can collision it because collision is full disable, and we can get to influence using, for example, overlapping or using some custom primitive data to this grass. So I made some, I suppose, interesting thing. What I made it, if we open our example wind explosion, we set up our data not just in, for example, our 1 second, for example, our parameter collection or just directly in material, but we set up this data in the texture per pixel, and after when we finish with our grass, we read this data using our a little custom HLSL code. For example, here our texture, let's me open paint. I suppose that's the best way to explain. We have a texture. The texture have it's one big texture with 0 pixel here and as many pixels as you want here. I have the only 40 pixels. Every pixel in this data collect the information about our explosion. For example, here I have first pixel have 3 channels to set up the position of biggest explosion, and 1 pixel to get a strength, and the second pixel that same contains information of our explosion too. That have start time, duration, radius, and valid. When we start the explosion, we set up this data in this pixel using render target, and after this we read it in the material and influence about the grass, about our weapons shader or any other thing. If we, for example, we have second explosion, we set up it at the third and the fourth pixel here, and ecote. When the, for example, our explosion is gone, we just clear this pixel and we can put the new explosion here in this data. The main idea of this system is that first of all we have here the one small subsystem that I write using my upgraded world subsystem. That's very simple. That just that's a basic subsystem that we can, for example, get wind explosion subsystem and to get ref to it, and they have just the logic to register some explosion and get it unique index that we put it in our paint pixels graph, and some other logic, because what's the main powerful of this system this is that we can change our number of our pixel using at runtime. That's, for example, if we have enough pixels to put some effects, as many explosions as we want, we just resize our render target and to have more space for our system when we, for example, thought first. And the second wave, that's our explosion. That's just set up our data in these pixels. Let's continue with the material explosion. That's very simple. We put using our Win explosion material collection just two data. We put it explosion count because this is we parse our array as much as we have this explosion count. And the current time, because we have only local time when we're using time node, and we need to global time to calculate our explosion radius. So after this, we just parsing material, get all data that we want, just create some curve to using where our explosion wave now, and after it returning this material function, and the base of our landscape see something like this. 1 second please. That's something here. Oh yeah, this is my plans. We just receive our wind function, clump it to make it more logical, and after it put it in our web offset shader. So I suppose this method is not have based optimizing because, for example, if we have our explosion that out of our camera that influence on the material too, and this is optimization part that we need to write it by ourselves. For example, receive at the decide at the blueprint site which explosion we need to register or which explosion we not need to register to make the rendering of our material is little more cheaper. So, and then second, the last thing that I want to show you, we're using here the one node that it's important for us. That's just a C++ set pixel node, but that's very simple, and that can be implemented only in the blueprint. And we have the resize render targeted place, but I still experimented with him, and I'm not just want to show you how it's exactly works. So, but I suppose that we have only 22 pixels here to our render target, and I think that's enough to create as many explosions as we want. So that's all. If you have any other question, just notify me. I'm ready to answer it. Goodbye.